Hi everyone, this is your math guru. In this video, I'm going to show you how to simplify trigonometric values that are represented by letters. Please don't forget to click on the like and subscribe button below for more easy to understand math concept. When a trigonometric value is represented by a letter, other trigonometric ratios or expressions can be written in terms of the given letter. What we use are we have reduction, we can use cofunctions, we can use trigonometric ratios, we can use compound or double angle formula, and we can use basic identities. What to use is dependent on or determined by what the question says. Let's look at the example given. We have if sine 14 degrees is equal to k, write the following in terms of k. The first question says sine 194 degrees. In order to reduce my sine 194, I'm going to use my cast diagram. I have C, A, S, T in the first quadrant. I have theta or 90 degrees minus theta. Second quadrant, that's 180 minus theta. Third quadrant, 180 plus theta. And in the last quadrant, I have 360 minus theta. If you look at sine 194, that falls in the third quadrant. And in the third quadrant, the reduction will be sine 180 degrees plus, I need to look for the value that will make up for 194, that's 14. Because 180 plus 14 is still the same as or is equal to 194. And therefore, using the code for the third quadrant, only tangent is positive, so therefore sine will be negative. Sine of the angle, so that's negative sine 14 degrees. And we've been given sine 14 degrees to be equal to k, so therefore sine 194 degrees will be negative k. In the second example, or in the second question, we have cos 76 degrees. Like we did for 76 degrees, that's in the first quadrant. Using reduction, I can break that down as cos of 90 degrees minus 14 degrees. Using cofunction, cos of 90 minus theta is equal to sine theta, so that's equal to sine 14 degrees, and we've been given sine 14 degrees to be equal to k, so cos 76 degrees is equal to k. And the third question, that's C, I have cos 14 degrees. Now, because it's the same acute angle as a sine 14, using the cast diagram again, I'm going to draw the quadrant in which we have a 14 degrees, which is the first quadrant, because it's an acute angle. So if I have 14 degrees, using my sine 14, if I have sine 14 degrees equals to k, we know that sine is equal to, that's using our trig ratios, that's opposite over hypotenuse. So labeling our diagram, we have that as the right angle triangle. The whole number is over 1 to make it a fraction. So the angle or the side facing the angle is the opposite, and that's a k. And then the hypotenuse is the side facing your right angle or the longest side, that's 1. So we need to find our adjacent. Using Pythagoras theorem, to find the adjacent, we know that hypotenuse squared is equal to opposite squared plus adjacent squared, because we are looking for our adjacent. So I have adjacent squared, making that the subject of formula, equals hypotenuse squared minus opposite squared. In this case, that's equal to the hypotenuse, that's 1 squared, minus the opposite. I'm going to label my diagram. I have the side facing my angle, my opposite. The longest side is my hypotenuse, and the third side is my adjacent. So my O is k squared Therefore, to find a, I'm going to find the square root of both sides. So that's 1 minus k squared. So going back to our cos 14, we know that cos theta, we have cos 14 degrees is equal to adjacent over hypotenuse. Adjacent has been given as roots of 1 minus k squared as calculated over hypotenuse, which is 1. So therefore, cos 14 degrees will be equal to root of 1 minus k squared. The next question says find sine 28 degrees. If you look at sine 28 degrees, I know that 28 is a multiple of 14. So I can rewrite that as a double angle. So I have that as sine in bracket 2 times 14 degrees. So using the double angle identity, that will be 2 sine 14 degrees cos 14 degrees. And because we already know the value of sine 14 and cos 14, I have for sine 14, that's k, so I have 2 times k times, and then for cos 14, we got that as root of 1 minus k squared. So rewriting that, sine 28 will be 2k root of 1 minus k squared. For the e path, we have to find cos 28 degrees. I'm going to use the double angle also. That's equal to cos of 2 times 14 degrees. And using the double angle expansion for cos, I'm going to use the one that says, or the identity that says 1 minus 2 sine squared 14 degrees. We know sine 14 to be k, so that will be 1 minus 2 times k squared. The next one, for our f says, I'm going to write the values here, sine 28 is 2k root 1 minus k squared. Then for f, we have tangent of tan 28 degrees. Note that the identity or the trig identity that changes tan to sine over cos, so that's the same as sine 28 degrees over cos 28 degrees. And because I already have the value for that, sine 28 is 2k root of 1 minus k squared, and then cos 28 is 1 minus 2k squared. So therefore, that will be my answer for that. Then I go to G. I have G as cos 44 degrees. I'm going to use my reduction or my double angle. If I use my double angle, I'll be able to break 44 degrees into a special angle and the angle given, that's 14. So I know that 44 degrees, if I break that down using double angle identity, that will be 30 degrees plus 14 degrees. And using the cos a plus b expansion, that will be cos 30 cos 14 minus sine 30 sine 14 degrees. 30 degrees is a special angle, so cos 30 will be root of 3 over 2 times cos 14. Cos 14 is root of 1 minus k squared. Then I have minus sine 30, that's a special angle, so that's 1 over 2 times sine 14, that's k. So if I simplify further, I have that as square root of 3 times 1 minus k squared. I'm applying the third rule over 2 minus k over 2. I'm putting that under the same denominator. I have that as root 3 minus 3k squared minus k all divided by 2. And for our last but not the least, I still have 2 questions left, so I'm moving to my edge. That will be, I have sine 7 degrees cos 7 degrees. That is looking like a double angle identity. If I have sine of 14 degrees, which I can break down as, so I'm going to start with sine 14 degrees. I'm going to write that properly. Sine 14 degrees is equal to sine of 2 times 7 degrees, and that's equal to, using the double angle identity for sine, that's 2 sine 7 cos 7. So in order to have sine 7 cos 7, I'm going to divide that by 2. So dividing both sides by 2, what I'm going to have is, I have half of sine 14, and we know that sine 14 is k, so I have half of k is equal to, then I have 2 into, that goes off, so that's sine 7 degrees cos 7 degrees, which is our answer. So that's also equal to k over 2. So sine 7 cos 7 is k over 2. And now for I, we have I to be 1 minus 2 sine squared 7 degrees. We have cos 14 degrees using the double angle identity, that's cos 2 times 7 degrees. And cos 2 alpha using our expansion for double angles, that's equal to 1 minus 2 sine squared 7. And 1 minus 2 sine squared 7, that's equal to what I got in the last, or in my C part, I was able to get the value of cos 14. So in order to get 1 minus 2 sine squared 7, that's also equal to cos 14 degrees, and cos 14 will be root of 1 minus k squared. Thanks for watching. Bye.